Hello and welcome back to this how-to guide for our GDSLAB software. In this video I would like to show you the concept and how virtual transducers work. First thing I'll do is just open up a station as an example. There's no devices connected to my computer at the moment, so we'll try and find some that we're going to carry on anyway. You can see we have a load frame, a serial pad, a USB pad, and two controllers. So very, very typical tri-axial setup. What I'm going to do is go into edit mode of the system builder and give an example that, let's take the back pressure, which is currently read from the controller. If we didn't have the controller, or we didn't have any way of reading that back pressure, I could click on here, this box, and set up a virtual transducer. And it's virtual because it doesn't exist. And we set up, once it's virtual, we can set up a formula for what parameter will be read and calculated into those raw data parameters. So as an example here, our back pressure, very, very similar to the way we do custom calculations, which is another chapter in the handbook. I could say that back pressure was always read as a crazy example, cell pressure minus 20 kPa. So if the cell pressure is reading 100 kPa, it will always read the back pressure, in this case, as 80 kPa. Maybe you've got a manual test running and that's how you're running the test, and you just don't have a transducer that's going to be able to measure that. So there, that would set up that back pressure as a virtual transducer. So a transducer that doesn't exist, but we want one of these primary parameters to be set based on a calculation. Now, maybe a better example might be axial displacement. If I just click on here, axial displacement, I might want to set this as a virtual transducer. Perhaps if I did have two axial LVDTs on the sample, one on each side of the sample, and I wanted to write in this formula, haven't got any, but I wanted to write in this formula axial LVDT1 plus axial LVD2 divided by 2, then I've set up a virtual transducer which will nicely give my axial displacement as the average of the two. So that, I think, is a better example of how a virtual transducer can be used. I hope that helps. Thank you.